Hello, this is Mr. Henry, and welcome to lesson 4.4, Solving Proportions Using Cross Products. Central question says, how do I solve proportions using cross products? So the warm-up, it asks, what is the process for solving a problem with a proportion in it? It's more of like just thinking about, do you remember proportions? So what do you remember about solving proportions? Do you remember the cross multiply? Do you remember the method? So I'm going to start off by saying there are some different methods I've seen for cross multiplying. Some of them I like, some of them I don't like. I'm just making up some random numbers here, by the way. So 3x, 5, 8, whatever. So I see this one method called the fishy method, where you start, like if the variable's on the top, you start on the bottom or the other way around, and you just take this thing times this thing, divide by this thing, gives you that thing. So it kind of looks like a fish, right? I don't like this fishy method because it does not always work. It's a shortcut to help with some of the simplest, easiest proportions. But if you do normal cross multiply the correct way, it works for every single problem, no matter how ugly they look, how easy they look, it will always work. So I prefer using actual cross multiplying, which, well, we'll see here in just a few minutes, to do these problems. There are some other shortcut methods I've seen. There's one like a butterfly method or something, but those again are shortcuts that work sometimes. The way we're going to cross multiply works every time. So a cross product, cross multiply, a cross product is the product of the numerator of one ratio and the denominator of another. And that's what we're going to be doing. Nothing much to say here because we'll see all this stuff in these next couple problems. Example 1 says, solve each equation. Be sure to check your solution. So if you look at example A here, what we're going to do, the way we're going to actually cross multiply is I take this number, multiply by this number, and put my answer right here. So 20 times by 5 is 100. On the other side, 16 times by m is 16m. Now look what that gives me. That gives me an equation. Do you see why it's also called cross multiply? You're multiplying diagonally. It makes this little cross in the middle. Looks like a multiply sign. So 16 times by m, 20 times by 5, and we get a little one-step equation, which we know how to solve. That variable is being multiplied by 16, so if we divide by 16, these cancel out, m equals whatever 100 divided by 16 is, 6.25. Okay, so the process is you cross multiply, and that gives you that step. And after you cross multiply, you solve. That's what we did. As far as checking our solution, we could plug that in. We could check to see if we plug in, I'm going to move this over for right now. 6.25 over 20 should be the same as 5 over 16. You could check this a couple different ways. You could take 6.25, divide by 20, gives you 0.1325, and clear. 5 divided by 16 should hopefully give us the same thing. Yay. Another way to check is you could cross multiply these. So 20 times by 5 is 100. 16 times by 6.25 is 100. So that checks out. So let me erase this, move this guy back over. I need the B as well. There we go. So we're going to cross multiply letter B. Now this one's a little bit different. This one has two variables. It doesn't look quite so simple. This is an example where that fishy method doesn't work. So if you were taught that method, I would like you to do the best you can to unremember it And look at this new method. So if I would take here x times 8 and put my answer here, and I would take x minus 3 times by 4, put my answer there. Now if you think, I don't know how to multiply that, you do. What this literally says is it's 4 times by x minus 3. 4 times by all of this stuff. 4 times by all of this stuff. We're going to distribute. We're going to take 4 times the x and 4 times the 3. So 4x minus 12 equals 8x. To continue solving here, we've got variables on both sides now. So this is just a normal equation like we saw in previous lessons. And this problem, I will actually highly recommend, instead of getting rid of the variable on the right, we get rid of the variable on the left. I'm going to do this because it's going to save us some steps. Because if we get rid of this guy, let's play pretend, if we minus 8x and minus 8x, then what we're going to have to do is to add 12 to both sides and then divide by negative 4. But if we minus 4x, what you'll see is we're actually going to save ourselves a step. Oopsie. 8 minus 4 is 4. Because now the variable's on one side, this constant term is on the other. They're already separate. I don't have to go through another step of separating them. And finally, divide by 4, giving us x equals negative 3. So we could check that out. So if we had 4 over negative 3, and then 8 over negative 3, and negative 3 is negative 6. Well, I can tell you this works out, because look at this. This times by 2 gives you that. This times by 2 gives you that. This is a proportion. This works out. Both sides, if you multiply diagonally, you get negative 24. Still works out. Letter C. We're going to cross multiply here, so let's see. 3 times by this stuff goes here. So I'm going to do this without writing it out, just to save an extra step. So 3 times x is 3x. 3 times negative 4 is negative 12. I'm still doing the distributive property. I'm still doing 3 times x minus 4. I'm just kind of doing that in my head, which gives me that. On the other side, 9 times x. Variables on both sides. Subtract the variable on the right here because that gets this 12 by itself. Ooh, 3x. This cancels, giving me 6x equals negative 12, and it is still negative. Don't forget about that negative sign. It's still negative. Divide both sides by 6, and x equals negative 2. To check our solution, negative 2 over 3 equals, let's see, negative 2, and negative 4 is negative 6 over 9. The diagonals should be the same. This gives me negative 18. This gives me negative 18. That is true. Letter D. Cross multiply here. 8 times n is 8n. 8 times 8 is 64. Cross multiply here. 3 times 5n is 15n. 3 times negative 2 is negative 6. So I'm doing the in the head distributive property here. I'm taking the 3 times by all the terms down here and the 8 times by all the terms up there. This gives me an equation with variables on both sides, so I solve it like we did in the previous lesson. I'm going to minus 15n here, minus 15n here. These cancel. This will give me negative 7n plus 64 equals negative 6. Again, it is still negative. Add 6. No, no, don't add 64. Subtract 64 because it's already positive. You want to subtract it away, giving you negative 7n equals negative 70. That works out a lot better. Divide by negative 7 on both sides, and n equals 10. And if we check our answers, I'm plugging it up here. So we have 10 plus 8 is 18. 5 times 10 is 50. Minus 2 is 48. And 3 and 8. This guy times by 6 gives you that. This guy times by 6 gives you that. So this is a proportion. This works out. Here are 4 for you to try. If you could please pause the video, do them on your own. When you're ready to continue, hit play, and we'll go through them together. Alright, here we go. So we're going to cross multiply. 1 times 3g is 3g. 2 times by g plus 5. See, 2 times g is 2g. 2 times 5 is 10. We have a little equation, variables on both sides. I'm going to get rid of the 2g. And that is actually going to be an easy equation because I'm going to get 1g equals 10. And if you plug it in, you get the same thing on both sides. You get the proportion works out. Again, I'm going to skip the checking of equations right now, simply to save some time on the video. You can check on your own. It works. Nice little easy problem, letter F. 3 times 4 is 12. 8 times x is 8x. Divide by 8 on both sides. X equals, see these cancel out, 12 divided by 8 is 4/3, 1 point, no, not 4/3, 12 divided by 8, yeah, 1.5. And that works out as well. Okay, so cross multiply this side, cross multiply that side. I'm going to do this side first. So 5 times h plus 8. 5 times h is 5h. 5 times 8 is 40. The other side, 2 times h is 2h. 2 times negative 1 is negative 2. So I've cross multiplied. Now, get rid of the variable on the right. We're going to solve this equation. So I'm going to minus 2h. These cancel out. That gives me 3h. Subtract 40 on both sides. We are almost done. Negative 42. Divide by 3, divide by 3. This should be old news by now. I'm not going to go too slow and explain every single step. Hopefully by now you should get it. If not, go back and watch previous videos again. That gives me, I don't know, 42, I messed up. 42 divided by 3, negative 14. Lastly, letter H. Let's see, 56 times by 9. I do not know that off the top of my head. 56 times by 9 is 504. 4 times 126b gives me 504b. That one I can do in my head. Divide both sides by 504. So we're solving the equation. B equals 1. And we're done. Here are 4 more practice problems. Go ahead, pause the video, try them on your own. You're ready to continue, hit play, and we will go through them together. Letter I, let's start by cross multiplying. 3 times by p plus 5 gives me 3p plus 15. 1 times by this stuff is just going to be that stuff, so 3p minus 2. I'm going to subtract 3p on both sides. These cancel out. These also cancel out. Interesting. So this is one of those special solutions because our variables canceled out on both sides. So this guy has no solution because this is not true. Negative 2 does not equal 15, so this is no solution. Letter J, cross multiply here gives me 6x plus 12. Cross multiply here gives me 12x minus 24. Minus 6x, minus 6x. We're solving the equation now. This cancels. 6x minus 24 equals 12. Add 24 to both sides. You have 6x equals 36. I'm going to jump over here. Divide both sides by 6. Cancels. X equals 6. Letter K. Cross multiply, as always. This side gives me a nice easy 56. This side gives me a 3x plus 9. Minus 9, minus 9. I'm solving the equation. 3x equals 56 minus 9. 56 minus 9 gives me 47. Divide both sides by 3, we get some ugly number because this is not going to work out. 47 divided by 3 is 15, and this is the decimal expansion for 2/3. 2 divided by 3 is the 0.6666, so it's 15 and 2/3. And that's our answer. Not every answer is always going to be a nice, pretty, easy number. Some of them are going to be fractions or decimals. You could write 15.6 repeated like that equals x. That's fine too. But just don't freak out every time there's an ugly number. Doesn't mean an ugly number is wrong. It's just ugly. Letter I, or L, it's an L. This is an ugly problem. I mean, fractions inside there? But we can still do it. We'll start the easy side first. So 7 times by this stuff gives me 14x plus 63. That's 7 times 2x is 14x. 7 times 9 is 63. The other side, maybe I'm going to write this one out. 3 times by the 1/5 minus x. I mean, this is kind of what I've been doing. I'm just doing most of it in my head. So 3 times the 1/5, 3 times that. That is negative 3x, so he's easy. 3 times by 1/5 is 3/5. Make both things a fraction. 3 times 1 is 3. 1 times 5 is 5. Alright, let's solve this thingy. I can't simplify anything on either side. There's no more parentheses. There's no combining like terms. I do have variables on both sides. So if I minus 14x minus 14x, these cancel. Negative 17x, it's over here. And 3/5 here. Let's see, I need to get rid of this piece, so since this is positive, I'm going to subtract it away. This is not being multiplied by the variable, so I'm not going to do the reciprocal. I'm going to, well, since it's positive, I'm going to subtract it away. Minus 3/5. See, 63 minus 3/5 would be 62 and 2/5. Which, if you like decimals better, would be 62.4. Might be easier for plugging numbers into the calculator here, which we probably will be, because I have no clue what we get if we divide this thing by negative 17. I know it's going to be a negative. So let's see. 62.4 4 divided by 17 negative equals, ooh, yummy, negative 3.67. Dot, dot, dot. No dot, dot, dot. That makes it look like it's repeating, but it's not. So about negative 3.67. Again, ugly answer, but that's okay. Let's get some applications. Example 2a says, in the diagram below, triangle ABC is similar to, remember that's what this symbol right there means. It means similar. And if you remember from module 3 and 2, or I guess module 3, similar means proportional. Hence, we're probably going to be using proportions. So triangle ABC is similar to triangle A prime, B prime, C prime. Using what we know about similar triangles, that they're proportional, determine the value of x. Okay. If AB is similar to A prime, B prime, x minus 2 over, I want to say this side is the AB, so the similar would be the A prime, B prime, 9.5. Down below, the AC is x plus 2, and the A prime, C prime, the corresponding side, is 12. It's not an ugly proportion. We can cross multiply him without too much trouble. This side, we'll change color here. 12 times by x plus 2 is 12x plus, minus, not plus, minus 24. And x plus 2 times by 9.5 is 9.5x plus, that will probably be 19, if my memory serves me right. 9.5 times 2 is 19. All right, so we have a little equation. Since we cross multiplied, let's solve. Subtract 9.5x on both sides. I'm getting rid of the variable on the right. He cancels out. Negative 24 comes along. Positive 19 comes along. All right, let's see. 12 minus 9.5. That's going to give me 3.5, I believe. 12 minus 9.5, 2.5. Ooh, I was wrong. Yeah, 2.5x. See, it's always good to check the calculator. Even though most of these times I say, I think I know the answer, but I still double check. Occasionally I'm wrong, and that's enough for me to still want to double check with my calculator. Okay, to continue solving, so we're going to add 24 to both sides. 2.5x equals, that's supposed to be 24. Let's see, that's going to be a 3, carry the 1, 43. Divide both sides by 2.5. X equals, let's see, where's my calculator? Let's see, 19 plus 24, 43. Yep. Divide by 2.5 equals 17.2. So the value of x is 17.2. And that's what we had to do. I should check in the directions again. It says, determine the value of x. We did. X equals 17.2. So I set up a proportion because the shapes are similar. They're proportional. I cross-multiplied my proportion. I solved the resulting equation. And I got x equals 17.2. Next example. It says, in the diagram below, wxyz is similar to w prime, x prime, y prime, z prime. What is the difference in the areas of this rectangle and that rectangle? So we want to find the difference of the areas. That's our goal. To find a difference of the area, I'm going to take the area of the big one minus the area of the small one, and that's going to be the difference of the areas. mean, a difference is a subtraction. So if I find the area of the big one, the area of the small one, plug them in, that's the difference of the areas. Okay, let's see. So the area of the big rectangle, area is length times by width. My area is 8 times by 18 is 80 and 64 is what, 144? 8 times by 18. 144. Yay! I know the area of the big one. 144. Now I need to find the area of the small one. In order to find the area of this small rectangle, I need to know what this x is, because I need to know how long those sides are. So let's find the x. Well, since these shapes are similar, let's use a proportion. 8 corresponds... Oh, I should do it this way. Same idea, different way of writing it. 8 corresponds to the x plus 3. The 18 corresponds to the 3x plus 6. If I solve this, I get the x. So find x. If I solve this, I get the x. I then use the x to plug it in up there and there to find the lengths of the sides, which I can then use to find the area of the rectangle, which I plug in here. That's our goal. That's the step-by-step of what my plan of attack is. Okay, let's cross multiply. This times this gives me 24x plus 48. 18 times by that gives me 18x plus 18 times by 3. 54. Okay, there are my two sides. I cannot simplify anymore on either side, so I'm going to go through and start solving. Get rid of the variable on the right. There we go. Minus 18x. He cancels out. That's going to give me 6x plus 48 equals 54. Minus 48 on both sides. 6x equals 54 minus 48. That's going to be 2 plus another 4 is 6. Divide by 6 on both sides. X equals 1. Okay. So if the x value is 1, 1 plus 3 is 4. 3 times 1 is 3, plus 6 is 9. So the area of that rectangle is now area equals length times width. 4 times by 9 is 36. So I found the x to plug it in because I needed to find the area of the small shape. The area of the small one is 36. Finally, we can find the difference of the areas. The difference of the areas is the area of the big one minus the area of the small one. And 144 minus 36, 144 minus 36, 36 equals 108 inches squared. Oh, yards, I'm sorry. I didn't even look at the label. I just took a random guess at it. It's yards squared. These are yards. Yard squared, yard squared. There. So my driving goal in the problem was to find the difference of the areas. So this was like my big goal. I knew I had to find the area of the big one and subtract it from the area of the little one. Thankfully, in the big rectangle, I had my two side lengths already. I could find the area and plug it in. Boom. Easy. To find the area of the small one, I had to know what the x value was, because if I could plug in the x value, I could find the lengths of those sides. So to find the x values, we had to set up a proportion, since the shapes were similar. And I cross-multiplied my proportion, solve, 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 solve. The x value is 1. We take the 1, plug it in. to give us the lengths of these sides. So now we can find the area of this rectangle, which was 36. And that can be plugged back in here. The area of the small triangle is 36, and so my final answer, the difference of the areas, is 108 yards squared. Complicated problem. That's why it's a DOK2. It takes extra steps to solve. It's not just a one-step wordy problem. It took a couple steps, couple planning steps in order to solve. Okay. I have a problem for you to do. This is example C. It says if JKLM is similar to J prime, K prime, L prime, M prime, find the perimeter of JKLM. So you want to find the perimeter of the larger shape. Go ahead, pause the video, do it right now. When you're ready to continue, hit play, and we will go through it together. Okay, so in order to find the perimeter of this shape, we need the length and the width. Actually, I'm going to move this further down. So we need the length and the width. So you could call this side the length and this side the width if you want. So perimeter is 2 times 6 plus 2 times... We don't know how big this is. We don't have a number for that piece. So our goal here is if we can find out what that x is, we can then plug it in, get the length of this side, and then find the perimeter of this shape. So our goal is to find x so that we can plug it in here. That's our goal. Okay, so let's find the x value. Since these shapes are similar, we're going to use a proportion. 6 corresponds to 1.5. X plus 6 corresponds to x minus 6. We're going to cross multiply here. This side times by that side gives me 6x minus 36. And 1.5 times by that gives me 1.5x plus, I believe that's going to be 9. Clear. 6 times by 1.5 equals, yepers. And now we solve. Minus 1.5x minus 1.5x. These cancel. Let's see. 6 minus 1.5, 5.5. 5. No. 5, 4.5. X. And add 36 to both sides. These cancel. 4.5x equals, let's see, 9 plus 36 is 45. Divide both sides by 4.5. 4.5 is cancel. X equals, the answer is going to be 10. Because if you take 45 divided by 4.5, you get 10. So that's the x value. So this x value is 10. This one as well, but we don't care about this guy. The problem says find the perimeter of JKLM. That's this larger rectangle. So I don't care about him. This is 10. So this length, or the width I should say, the width is 16. And that's the information I needed in order to find the perimeter of that shape. So the perimeter is 2 times 6 is 12. 2 times 16 is 32. Add them puppies together, you get 44, and do I have a label? Centimeters is my perimeter. My goal was to find the perimeter. I wrote down my formula. I plugged in what I knew. I found out what I needed to find. I needed the x so I could find the width. So I went through and I found the x, plug it in, evaluate. The summary says, how do you solve problems using cross products? Give me a little summary. What are the steps we went through in solving these equations or these proportions? Go ahead, pause the video, and when you're ready to continue, hit play. We'll go through it together. So my summary basically comes down to, it says you solve problems using cross products. To solve problems using cross products, you cross multiply the proportion. That gives you an equation that you solve like in previous lessons. And that's really what it comes down to. You cross multiply, solve the equation. That's it. That gives you your answer. This has been lesson 4.4. Thank you for watching.